So, Ellie's not here tonight, and I'm kind of sad about it. Anyways, so we did missions about just going out into space, and I didn't know what to call it, and Ellie had a silly title. So, here we go. So, the first mission is Kepler. It was launched March 6, 2009 at 9:49 from Cape Canaveral, Florida. It was designed to take part of the Milky Way galaxy searching for exoplanets. Um, it it went on for 9.5 years, and in its 9.5 years, it collected 678 gigabytes of data. With all this data, 2,946 papers have been written, and 732,128 commands were used and executed. So, it identified and observed 2,800 maybe exoplanets, and 2,662 have been confirmed. It observed 530,506 stars, which is a crap ton. In 2013, Kepler was assigned a new mission called K2. In K2, it was specifically looking at the elliptical part of the, anyways, it's looking for something else, and I have it on another slide. Kepler ran out of fuel October 30th, 2018, so NASA retired, and it safely orbits around the Earth. Kepler spent 9.6 years in space and used only 3.12 gallons of fuel.
What? How can you only burn 3 gallons of fuel?
Gravity does for it.
Yeah. Once it gets up there and gets going.
Once we get into orbit.
Yeah. So this is just, it kind of doesn't turn up the way I want it. But here's a painting of Kepler. This is what Kepler looked like. I have a real picture. And all the exoplanets and everything that it had discovered at the time. So I just thought that was cool. So, this is what K2 did for Kepler. It searched along the plane of the galaxy called the ecliptic plane. So, ecliptic. It searched for exploded/exploding stars and distant supermassive black holes at the hearts of other galaxies. 61 supernova were discovered from this. So, this is our sun, and this is how far it was able to search out to. So it discovered all of the stars and supernovae and everything by using the transit method. So when this little planet or star, whatever it is, crosses in front of this star, the brightness is dimmed. The brightness of this is dimmed. So that's how we find out other celestial objects.
That's way over dramatized though.
Yeah. This isn't, yeah.
The blip is very minuscule, but it's so sensitive.
Yeah. So this is a picture of what the actual Kepler satellite looks like. This is its orbit. It was a heliocentric Earth trailing orbit, so it was slightly behind Earth, but not by much. It moves around the sun every 372 days. So it also, how to capture these very sensitive things is with a photometer, which is right here, and you can't really even see it. Photometer is a telescope designed that measures light intensity. So the smallest, thousandth of a degree off, it measures it. Alright, so now we have Juno. Juno launched August 5th, 2011 from Cape Canaveral, Florida. It's expected to run until July 2021, then it will impact into Jupiter. It cost $1.1 billion. Juno was made to study Jupiter's weather, magnetic environment, and formation history. Juno is a part of the New Frontiers program in NASA, created in 2003, which only has 3 missions. Finally, in February of 2016, Juno went on course to Jupiter. Before, we just had it in Earth's orbit, taking really cool pictures of Earth. Then, July 4th, 2016, Juno reached Jupiter. In August 2016, we discovered that the bands that around Jupiter go deep into the atmosphere, which I'll go into more later. July 2017, we discovered, so Juno flew 5,600 miles above the Great Red Spot, the Great Red Storm. We've been monitoring since 1830. Just found out 2 years ago, so 2017, that the deepest parts go 50 to 100 times deeper than Earth's oceans. So the deepest part of Earth is not even close. So this is what Juno looks like, and this is what it did. It went by Earth, and it went around, and then we went, we did some stuff out in space, and then we went to Jupiter. So these are just some pictures that they actually took. These pictures have not been altered at all. So this is Io's shadow. This was taken September 26th of 2019, so not too long ago. And this is the big red storm, obviously, and this is what I was referring to. It has been shrinking. Okay, so these are my really cool pictures, and these have not been altered either. So this picture is in the northern atmosphere, and these are the clouds that are sitting above there and everything. So I thought that was really cool. And then another picture is a jet stream. So this is just kind of a close-up picture right here. It extends over 1,900 miles. So it doesn't maybe look that big, but it's pretty big when you get to it. So now this is just like a not really panoramic, but so on the bands with the light regions, so like right here, that's where the gas is rising, and these darker regions are where the gas is sinking. So that's how we know like what gases it's made of because of densities and such. And I have one else really cool picture. So and here's just another flyby with the Great Red Spot and everything. So next is New Horizons. This is sort of just a little look at whatever. This is Ellie's part of the presentation, so here we go. So it took off, we went to Jupiter, and then we flew on to Pluto, which was its main mission. So this is New Horizons, this is the machine. It launched January 19, 2006 from Cape Canaveral Air Force Station. It was to fly by Pluto and its surrounding moons to just gain more information because we don't have a lot of information. So I'm going to tell you a little bit more about the spaceship. So REX stands for Radio Science Experiment. So this little satellite thingy. Alice, where's Alice? Alice is right here. An ultraviolet imaging spectrometer analyzes composition and structure of Pluto's atmosphere and looks for atmospheres around Charon and Kuiper Belt objects. So this was specifically made for Pluto and its moons. This wasn't like, oh, we're just going to send it there on a whim. We specifically made it to study them. Ralph, right here, this little disc, is a visible and infrared imager spectrometer, provides color composition and thermal maps, and I have a picture that used Ralph towards the end. And then the student dust counter was built and operated by students, actually. So it was kind of like a grant thing, like, hey, build the best one, you get to go. So it measures the space, dust peppering across New Horizons during its voyage. So any dust that came in contact with it, it would like kind of go up this tube and it would send data back. LORRI is Long Range Reconnaissance Imager, telescopic camera. It obtains encounter data at long distances, maps Pluto's far side, and provides high-resolution geological data. So it's a super powerful camera. SWAP is a solar wind around Pluto. It just measures the solar wind around Pluto. And then PEPSI is Pluto Energetic Particle Spectrometer Science Investigation. Energetic Particle Spectrometer measures the composition and density of plasma escaping from Pluto's atmosphere. So it's plumes and stuff. So finally what we learned, it passed by Pluto in July 2015, became the first spacecraft ever to visit Pluto. Everything else had just disregarded it. It flew just a mere 750 miles above the surface. It's responsible for observing a heart-shaped region of ice on Pluto and mountains made of ice. You can kind of see the heart right here. It was also the first mission to explore the solar system's third zone, or the region beyond the giant planets we all know and love. I love Ellie. It also discovered the 4 previously unknown moons of Pluto: Nix, Hydra, Styx, and Kerberos. It's responsible for the first high-resolution geological and compositional maps of small Kuiper Belt objects. So this is just kind of how it went. So it ended up here, but first, so here are the moons and everything, and then it flew by most of the moons, and then it went in 750 miles from Pluto. So here's some pictures it actually took. So this is Pluto, and its moon Charon, and there's a little bit better, you can see kind of the heart. And this is actually like a close-up photo of the geological surface on Pluto. And then this is what, oh no, I forgot what he was called. Ralph was used to take this picture. It's to show the difference between Pluto's distinct regions. So any difference between temperature or altitude, it gave it a different color. So I thought that was really cool. It also was able to find all these moons which we had previously not known anything about. So there you go.